The first remark says that if there exist n linearly independent eigenvectors for a matrix A which is of order n, then A is certainly diagonalizable. This is a kind of informal definition. This was a formal definition, but this is informal definition, and this definition, this one, is actually very helpful to understand what is diagonalizability. if for a matrix of order, suppose A is a matrix of order 10, मान लीजिए A जो matrix है उसका order है 10, और somehow you are able to have 10 linearly independent eigenvectors, right? Then you can say that A is diagonalizable. Okay, and if you are not able to get 10 linearly independent eigenvectors, then you can say that A is not diagonalizable. This is very straightforward, and this is very straightforward definition of diagonalizability. But unfortunately, the definition of diagonalizability, the formal definition, has been taken as this, which is students actually don't understand, right? What you understand this straightforward point number one. Please understand this point number one. Rely on this point number one. If you understand point number one, remark number one, you will be understanding diagonalizability. Okay. Now comes the second remark. The second remark says that if all the eigenvalues of A are distinct means different, right? Then A is always diagonalizable. This is also a good remark, a shortcut actually. Sometimes the question is asking about whether the matrix is diagonalizable or not. It means the question is asking for yes or no, right? And as soon as you get the distinct eigenvalues, you immediately say that, sir, yes, it is diagonalizable, right? This is a kind of shortcut. This second point number two can be used as a shortcut to answer, right? Third point is about the repeated eigenvalue. We know that if a matrix A has repeated eigenvalue, then it may or may not be diagonalizable. As you can see in question number 2, which we did yesterday, you can see that the eigenvalues were repeated, and this matrix was not diagonalizable since only one eigenvector was there. Second eigenvector was absent, right? But there are matrices which have repeated eigenvalues, and in spite of that, they are diagonalizable. I can give you example of a matrix which is having repeated eigenvalues. Example A, the matrix was 4, 3, 1, minus 1, 1, 3, 1, minus 1, 1. This is a matrix we took yesterday, has repeated eigenvalues, and those were, I think, 2, 2 and 2, and it is not diagonalizable, right? So this was an example of repeated eigenvalue matrix which was not diagonalizable. But there exist matrices like I say A equal to 2, 0, 0, 3. Can you see this matrix? Oh, sorry, should I write 2, 2 has repeated eigenvalues 2 and 2. If you find the eigenvalues of this matrix, you will be getting 2 and 2. Should I show that how to get the eigenvalues of this matrix? If you find the eigenvalues of this matrix, those will be 2, 2, using that shortcut formula. Use this formula to get the eigenvalues. In fact, you can find it. Let me write it. Since lambda square minus trace of A. What is trace of A? Trace is the sum of diagonal elements, that will be 4 lambda, plus determinant of A. Determinant of A will be 4 minus 0. That will be 4 equal to 0, implies lambda minus 2 whole square equal to 0, and that gives you lambda equal to 2, 2. That's why I have written that eigenvalues are 2 and 2. And it has repeated eigenvalues, but in fact this is diagonalizable. In fact, A is diagonalizable, and why I'm saying so, because this is a born diagonal match. पैदाइशी डायगोनल है ये तो पहले ही डायगोनल है. इसको क्या डायगोनल आप करेंगे? ये तो पैदाइशी डायगोनल है, right? Not gifted. As A is actually by birth DIAG 2, 2, right? So this remark is very important. Sometimes repeated eigenvalues gives diagonalizable matrices, and sometimes they don't. So these two examples are like in support of this third remark, right? Okay, now I will proceed further after making a box on these remarks, because these are very important. Question. Suppose eigenvector was, let me take it has 1, -1 and 2, no, 1, 1 and 2, 1. Okay, fine. Suppose 1, 1 and 2, 1 are eigenvectors of a matrix A corresponding to the eigenvalues 2 and 3. Find matrix A. Right? In this question, matrix is not given. But what is given? Given is the set of eigenvalues and the corresponding eigenvectors. Right? Matrix is not given. The question is kind of reverse question, what you did so far. Yesterday question and the day before yesterday, you were given a matrix actually, and you were asked to find eigenvalues and eigenvectors. But this question is asked in a reverse way actually. Eigenvalues and eigenvectors are given, but matrix is absent, right? So what we will do, we will just first we will use some notations. I will write that since we always denote eigenvalues by lambda 1 and lambda 2, these are the eigenvalues, right? And we denote eigenvectors by v1 and v2, 1 1 and v2 equal to 2 1. So these are the eigenvalues in eigenvectors. Okay, now you need to find the actual matrix A, original matrix A, right? To do that, we first construct a modal matrix. Since you can always construct a modal matrix, construct a modal matrix. Modal matrix is nothing but it is just the arrangement of eigenvectors column wise. If you write v1, this is your v1, and you write it here 1 1, and this is v2, and you write it here 2 1, then this is called modal matrix, and this is always invertible. It means that determinant is non-zero. This is very important point. If you find the determinant of this matrix, then that should be non-zero. Yeah, of course. Matrix is diagonalizable. Okay, Shikhar Upreti, you are correct. Eigenvalues are distinct. Matrix is diagonalizable, but they are asking for the matrix. Actually, they are not asking for the diagonalizability of A, right? They are asking for the matrix. You have to give a 2 cross 2 matrix. What is that matrix? The matrix is hidden actually, right? Shikhar, you got my point? The question is correct. Of course, what you are saying is correct, but the question is asking about the matrix A. You have to give matrix A. Okay, good, Shikhar. This is a modal matrix. Shikhar, can you find the inverse of this matrix? We have a very beautiful formula to find the inverse of a 2 cross 2 matrix. I revealed it yesterday this way. This is a shortcut trick to find a determinant to find the inverse of 2 cross 2 matrix. Just switch these elements, diagonal elements, and just change the sign of these elements and divide by determinant of A. We should do that. Switch the diagonal elements like this and change the sign of non-diagonal elements like this and divide by determinant. The determinant of this matrix will be 1 minus 2. That will be minus 1. So 1 upon minus 1. That ultimately gives you minus 1 to 1 minus 1. This is the inverse. Okay. And D is the diagonal matrix, and that is represented by DIAG, and then you write lambda 1 comma lambda 2. If you remember it, I mentioned it in this question. See, there's that question. Yeah, this one. See this DIAG lambda 1 comma lambda 2. This is your D, right? Okay, so that gives you DIAG 2 comma 3, or you can write it as 2003. Now, since you know this formula D equal to P inverse AP, do you know this formula? This formula is here. See this formula, right? And this formula was described in one of the steps. D equal to P inverse AP. See this, right? So D equal to P inverse AP is the formula. I'm using the formula. See, but I need to find A actually. D is given, P inverse is given, P is given. You need to find this A, right? And then on pre and post multiplication, I will do that in a single step now. P inverse A P with the red color. I am doing the post multiplication. You can see that with this red color, I'm doing the post multiplication, and with this green color, I'm doing the pre multiplication by P, right? And that gives me now P D P inverse. You can see that this will become the identity matrix. P into P inverse is identity. I will write it I and A, and this also becomes I, right? So I. So finally, it will give a new formula actually, and let me write with the A equal to P D P inverse. So this is a new formula you just have derived, right? You should remember it directly actually, because D was P inverse dP. You can see that D was P inverse dP, and this is A equal to P dP inverse. Okay, so remember this. -1 होना चाहिए, कहाँ पे होना चाहिए? P इनवर्स में ये साइन चेंज हुआ, ओके, और इसका नहीं, मुझे लग रहा ठीक है. This is correct. P इनवर्स यही आ रहा है. Because determinant is -1. I have divided by -1. मैंने एक स्टेप स्किप कर दिया है देवांश, और यही आएगा. ओके, आगे बढ़ते हैं. Therefore, A equal to, what is the value of P? The value of P is 1. What is happening today? 1, 2, 1, 1. Value of D is 2, 0, 0, 3, and P inverse is -1, 2, 1, -1. And if you multiply these, I am not wasting, please, I just don't want to waste time in multiplication. The answer will be this. I'm writing directly the answer because I know the answer. What is the answer? And how do I know the answer? Because I'm just doing the same question by modifying it again and again. I took this question. This was the matrix which I was hiding from you all, and I gave you these eigenvalues, and I gave you these eigenvectors. So this is how I designed this question. So that's why I know that this will be the answer. This will be my answer, right? 4 minus 2, 1, 1. And the rest of the calculation is for your homework. You can always multiply. What was that? 4 minus 2, 1, 1. No? 4 minus 2, 1, 1. Okay. This was the matrix. Vikatraj is asking something. Vikatraj, what are you asking?
Sir, I'm asking that, sir, ये जो आपने diagonal
अच्छा, eigenvalue.
put
Okay.
किया, yes sir.
ये वाला, this one, ये?
Yes sir, yes sir.
हाँ, of course. D is a diagonal matrix ना. D जो होता है diagonal में आइगन वैल्यूज ही तो आते हैं. कल भी तो बताया था इस क्वेश्चन में, देखो ना यहाँ पे, ये बताया ना, यहाँ पे ये बताया है, यहाँ भी बताया है,
Okay sir.
ऊपर भी है, थ्योरी में भी लिखा है, ये देखो ये लिखा है, थ्योरी में भी लिखा है.
Okay sir, thank you.
So this is a matrix A. Answer ये आएगा, ठीक है. Now coming to the next question. If 1, 1 and 2, 1 are the eigenvectors of matrix is given this time 4 minus 2 1 1. In exam, how can you write the value of a directly? Here I could write the value of a directly because I have this question number 2 and question number 3 was in my file. No? Yes or no? That's why I could write the answer directly because I have this question. No? But in exam, you will not be having these questions in your copy. No? Eigenvectors of A corresponding to the eigenvalues lambda 1 and lambda 2. Find the eigenvalues. This time the matrix is given, eigenvectors are given, but what is hidden? Hidden is the set of eigenvalues. You have to find eigenvalues. What are these eigenvalues, right? So again, the same question. Matrix is same. You can see that here. V1 is this one, V1 1, and V2 is 2 1, right? And note that recall. You should recall that what is an eigenvector? What is the property of an eigenvector? If you multiply the eigenvector with matrix A times V, then the answer is always lambda times of V. This is the property you should remember. Property of eigenvalues and eigenvectors, right? And we should write I here, lambda I V I, lambda I. Okay. Now, therefore, A times V1 equal to, what's the value of A? A is 4 minus 2 1 1. The value of V1 is 1 1, and if you multiply them, then 4 minus 2 will be 2, and 1 plus 1 will be 2, right? I hope you got this multiplication. And sorry, and you can take 2 common, and inside bracket you will be having 1 1, right? And of course this is nothing but 2 times of V1, right? So what is the eigenvalue? This should be the eigenvalue because lambda is the eigenvalue, right? So lambda 1 equal to 2. Therefore, lambda 1 equal to 2 is the first eigenvalue. Is an eigenvalue, right? Similarly, A times V2, and this is 4 minus 2 1 1, and the vector V2 is this one 2 1, and if you multiply them, you get 4 to 8 minus 2 will be 6, 2 plus 1 will be 3, and you can comfortably take 3 common, and inside this vector you will be having elements 2 1, and surprisingly this is nothing but 3 times of V2. Therefore, the second eigenvalue is actually 3, is second eigenvalue, right? So this is again the same question but asked in a twisted way. I'm just doing the same question since the beginning of this file. Please pay attention. I started with the same example. I didn't change my matrix. In all, see this matrix. Where is that? Diagonalizability. Yeah, see this matrix. See this. There's the same matrix. Example also, I was keeping the same matrix. Even at the beginning, I told you the answer. This is a D matrix, diagonal matrix, right? But these questions are just a kind of curtain raiser. पर्दा उठाने वाले सवाल हैं ये. सिर्फ पर्दा उठा रहे हैं इस थ्योरी पे जो मैंने लाल रंग से लिखी है, राइट? कोई नया सवाल नहीं है, हर बार एक ही सवाल घूम घूम के पूछा जा रहा है, ठीक है? और आप देख रहे हैं कि 3 चीजें आपके सामने हैं. वन इज मैट्रिक्स, second is the set of eigenvalues, third is the set of eigenvectors. तीन चीजें हैं अपने आप में, 3 एंटाइटीज हैं, मैट्रिक्स, दूसरी तरफ सेट ऑफ eigenvalues, तीसरी तरफ सेट ऑफ eigenvectors. इन तीनों में से कोई भी 2 दी होती है आपको और तीसरा आप हमेशा निकाल लेते हैं, matrix is given, eigenvalues are given. You can always find the eigenvectors like you found in first question, right? Second is matrix is not given, but eigenvalues and eigenvectors are given. You can find a matrix से तीनों में से दो चीजें दी हो, एक छुपी हुई हो, तो आप निकाल सकते हैं तीसरी। ठीक है, चलिए आगे बढ़ते हैं।
सर इसे वैसे पी इनवर्स वाले से भी निकाल सकते हैं क्या, पी इनवर्स एपी से?
पी इनवर्स एपी, हाँ हाँ, पी इनवर्स एपी से कैसे? पी इनवर्स एपी से तो डी निकलेगा ना, लेकिन डी इक्वल टू पी इनवर्स एपी होता है ना, आपको डी तो पूछा ही नहीं है, इससे तो
डी
डी
से
आएगा।
सर आप, हाँ फिर लैम्डा 1 लैम्डा 2 सर डी से भी तो निकाल ही सकते हैं ना।
अच्छा हाँ हाँ हाँ, ठीक है ठीक है ठीक है, हाँ निकाल सकते हैं। तो लो, जो तुम्हारा तुम जो कह रहे हो वो लिख ही देते हैं यहाँ पे, और करके ऑल्टरनेट मेथड इसका ये है कि आप निकाल सकते हैं डी इक्वल टू, यही कहना चाह रहे हैं हम, डी इक्वल टू पी इनवर्स ए पी, यही कह रहे हैं।
यस सर, यस सर।
और इसका मतलब होगा जब आप ये निकाल लेंगे तो ये जो आएगा, तो डी जो आएगा वो कैलकुलेशन से आ जाएगा, क्या आएगा 2 0 एंड 0 3, और ये हो जाएगा डी आई ए डी 2 3। तो ये वाला जो होगा, पहला वाला होगा दैट शुड बी लैम्डा 1, और जो दूसरा वाला होगा लैम्डा 2। हाँ बिल्कुल ऐसे कर सकते हैं, ये भी तरीका है, राइट। चलिए आगे बढ़ते हैं। राइट, यूज ऑफ डायगोनलाइजेशन में पढ़ क्यों रहे हैं, क्या इसका यूज है, राइट? एप्लीकेशन ऑफ डायगोनलाइजेशन कहना चाहिए, राइट? यूज ऑफ डायगोनलाइजेशन, ओके। तो इसका यूज तो बड़ा अच्छा है, अगर आप इसका यूज देखेंगे तो बड़ा खूबसूरत आपको लगेगा। आपको मैट्रिक्स अगर दियो तो आप उसका स्क्वायर निकाल लेते हैं। इफ यू आर गिवन अ मैट्रिक्स ए, कैन यू फाइंड इट्स स्क्वायर, यस और नो?
यस सर।
ऑफ कोर्स यस। क्यूब निकालना हो, क्यूब, ए क्यूब, ये यस। लेकिन स्क्वायर रूट निकालेंगे मैट्रिक्स का? कोई निकाला है स्क्वायर रूट ऑफ मैट्रिक्स?
हाँ सर।
हाँ, स्क्वायर रूट भी निकाला है मैट्रिक्स का? कब निकाला?
सर नहीं निकाला।
नहीं निकाला, तो वो अब निकाल, जो अब तक नहीं किया वो अब आप कर पाएंगे, राइट? ओके, देखिए कैसे निकालते हैं। तो इसको मैं बना देता हूँ रिमार्क के तौर पे, यूज ऑफ डायगोनलाइजेशन के लिए। सिंस अभी फॉर्मूला आपने डिराइव किया है a इक्वल टू पी डी, अभी थोड़ी देर पहले यहाँ पे हमने डिराइव किया, ये लिखिएगा। इससे आगे बढ़ते हैं। अगर मैं निकालूं देन, अगर मैं निकालूं ए स्क्वायर, तो ए इंटू ए ही होता है, तो ए की वैल्यू पी डी पी इनवर्स इंटू पी डी, दो बार लिखना पड़ेगा। इससे ये आपको सिंप्लीफाई करके देगा पी डी, आप खोल सकते हैं कभी भी, पी डी पी इनवर्स पी डी। तो इसको अगर एक साथ लिख दिया जाए, दैट विल गिव यू आइडेंटिटी डी, and this DID did P D square P inverse, because I into D is D, D into D is D square. So we just saw that when you put a power of 2 on A, it goes on D only, not on P and P inverse. Let us find the third power of A. Again, if you find A cube, it will be something like A square into A, and value of A square can be copied from here. There's no harm to copy from your own copy. That's not a cheating actually. अपनी ही copy से देख के लिखने को cheating नहीं कहते हैं। P D P inverse, and again using the same logic, you can write it as P D square. P inverse P in the middle can be clubbed like this, D P inverse, and that will become the identity. You know that P inverse P is the identity, so that will give you P D square I D inverse, and I into D is D, and D into D square is D cube. That gives you P D. हाँ एग्जाम में भी बिल्कुल अपनी कॉपी से देखने को चीटिंग नहीं कहते हैं। P D cube P inverse. So again, you observe that if 3 is put on the power of A, then this goes on the power of D only. Nothing happens to the power of P inverse and P. Right? So can we generalize this logic? Generalizing this fact that if you find the power of A, like A to the power n, then it goes only on the power of D, and that is a very beautiful thing, and that gives you hope to find the square root of a matrix. It means that if n is equal to half, then d to the n here n will be equal to half. N can be any number, and finding the square root of a diagonal matrix is very easy, because डायगोनल मैट्रिक्स के बारे में खूबसूरती होती है कि उसमें कहीं भी कोई एलिमेंट नहीं होते सिर्फ डायगोनल के अलावा. अगर आप कहेंगे कि फाइंडिंग द स्क्वायर रूट ऑफ अ डायगोनल मैट्रिक्स, तो कुछ मत करिएगा, जो डायगोनल में जो नंबर लिखे हैं उनका स्क्वायर रूट कर दीजिए, बाकी जगह तो जीरो है, जीरो का स्क्वायर रूट जीरो ही होता है. राइट. क्या तो ये उम्मीद आपको बना रहा है कि अब आप किसी मैट्रिक्स का स्क्वायर रूट भी निकालेंगे. मैं इस फॉर्मूले को बॉक्स बनाना चाहूंगा, क्योंकि मुसीबत के समय फॉर्मूला आपके काम आएगा. राइट. मुसीबत हो या कयामत हो, कभी भी ये काम आएगा आपके. ठीक है. तो ये डिडक्शन जो है ये बड़ा इंपॉर्टेंट है, और इसी के नीचे अब मैं थोड़े और डिडक्शन लिखने जा रहा हूँ. वो कुछ रिमार्क्स ऐसे रिमार्क्स ओके. फर्स्ट रिमार्क इज taken from this a to the power n equal to p d to the power n p inverse, and n can be any what should I say, integer fraction q. N belongs to q. Do you know what's q? Q is any rational number. Right? For example, you can always find a to the power half, and that goes p times d to the power half and p inverse, etc. Right. If you take a is equal to that much, let me again choose this a. Where is a? This is my a. Since from the beginning of this file, this has been my a. I will stick to this a. Let's find the square root of this. Right. If a is equal to 4, 2, minus 1, 1, this was my a, then square root of a, this is a to the power half, is a to the power half is a to the power half, and the value of p was, where is p? P. This is my p. Where is p? This is my p. 1, 2, 1, 1. 1, 2, 1, 1, and d was 2, 3, 0, 0, and its power is half, so half is power. And p inverse was minus 1, 2, 1. Now we have to multiply them, but before multiplication we should just take this square root of the matrix onto the individual elements. That will give you a square root of 2. This is 0, this is 0, this is square root of 3. Right. So this is a good thing about diagonal matrix. Finding a power of a diagonal matrix is easy, but it doesn't mean that, please pay attention, it doesn't mean that if you have numbers like 4, 9, 25 and 0, and if you are going to find the square root of this thing, then please notice that it doesn't mean that 2, 3, 5, 0. This is of course false. So please get sure. Finding the square root or cube root is only possible with the diagonal matrix. This step is only possible because this was a diagonal matrix. Right. Do not generalize this to this. What I have written here. I will make a box on it, and I should write a caution here. This is a caution for you. Right. Caution. Savdhani. Is a symbol for caution. Caution. And please, for any function, I haven't used any function. This is just fractional power. Are you talking about power? For any power, I think you're asking for any power. I mean square root function. Okay, fine. Yeah. For square root function, for cube root function, any root. Cube root is also possible, but that is possible with only this D. You can't do a square root or cube root of an ordinary matrix like this. This is absolutely wrong. Please see this sign, not equal to. Right? Okay. Now it needs to multiply these matrices 1, 2, 1, 1. And if you multiply this, you will get minus root 2. And you will get 2 root 2, root 3, and minus root 3. And now you multiply these things. Minus root 2 plus 2 root 2. This will be 2 root 3 minus root 2. This will be 2 root 2 minus 2 root 3. And this will be minus of root 2 plus root 3. This will be 2 root 2. Sorry, 2 root 2 minus square root of 3. This is the answer. This is the square root of this matrix. See the square root of this matrix, right? And of course, note that I will write caution again. Note the square root of this matrix, because this is not a diagonal matrix. You can see that is not equal to. I will say it's not equal to square root of 4, square root of 2, square root of minus 1, square root of 1. So please do not do this. This is not equal to, right? That's why I always say, please take my original notes. Sometimes what happens that I write not equal to and students copy equal to. This is possible. These are the mistakes which everybody makes. Even I made in my career, right? Okay. Fine. So now you all know that how to find the square root of a matrix, right? And not only square root. The second remark is more general, right? If f of a is any function defined for a, then please pay attention. Again, I am copying this beautiful equation. Not this, actually this equation. Where is that original? This one, APDP inverse. Yeah. Then A equal to P D P inverse. This was the original equation when we started with. Since I just told you that whatever you do with this A, that happens with the D only, right? This was my main motive. So whatever function applies to that A, the same function applies on D and nowhere else. Please leave those P and P inverse standing at the corners as they are. Do not just touch them, right? This is a new relationship. I will highlight this. Right. For example, you can take a small example for this. For example, if you want to find if A is again that same A, I'm not leaving that A, 4 2 minus 1 1, and you want to find e to the power A. This is something very strange. We are going to find the power of E, and the power is not a number today, it is a matrix. Right? So this is a new thing you are learning in BTech. Since now you learned how to find e to the power x exponential series, you all know that, right? This time you are finding the e to the power A, where it is not a number, A is a matrix, right? You have to find e to the power A equal to question mark. This is your target, right? And since e is an exponential function, right? See, this is your EA, right? So since A equal to P D P inverse, so if you raise this matrix A to the power of E, then this D will be raised to the power of E also. And this is possible because e to the power x has an infinite series expansion, And if you remember the expression of e to the power x, that is 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on, so on, so on, so on. It involves the positive powers of a positive powers of x actually. And if you replace x by a, you will get e to the power a equal to 1 I plus a square by 2 factorial plus a cube by 3 factorial and so on. All the positive powers of a can be computed very easily. So that's why this step is valid. It's a kind of infinite polynomial looking like series looking like a polynomial. That's why this step is feasible. Okay? So that gives you p. The value of p is what? What is the value of p? 1, 2, 2, 1. 1, 2, 1, 1. The value of e to the power d will be e to the power square and e to the power 3. You can see that those eigenvalues just raised to the power of e, and p inverse was nothing but it was minus 1, 2, and 1, minus 1. Now it's just need to multiply them, right? Multiply them. 1, 2, 1, 1, and if you multiply these, we'll get e minus e square and 2e square, e cube and minus e cube, I think, yeah. And now multiply these two, we'll get 2e cube minus e square, and that will be 2e square minus 2e cube, and this will be e cube minus e square and 2e square minus e cube. This is the value of e to the power. So whatever we do with a, we have to do with, yes, of course, so you are right. Whatever you do with a happens with the d, and this is the second time I'm saying this. Earlier I told that 2 lectures back, I told that whatever you do with the matrix, the same happens with the eigenvalues. This was my last statement. But today our statement is modified. I'm saying that whatever you do with matrix A, the same happens with the diagonal matrix D. But please notice that what is D? D is the matrix, diagonal matrix having the eigenvalues on the diagonal, right? So these two statements are correlated actually. Since the matrix, diagonal matrix D is having eigenvalues on its diagonal, that's why whatever is happening to A, the same is happening to D, because D is nothing but a structure having eigenvalues on its diagonal. So my earlier statement was is again absolutely true, and it stands absolutely correct today also. Whatever you do with matrix, same happens with eigenvalues, right? So this is e to the power a. Okay, solution right. And now 7 minutes left now. Yeah, we have found the square root. Now we should move to the 3 cross 3 matrix. So far in these 2 lectures, we have been sticking to 2 cross 2 matrices. But now comes the time where we should move to the bigger matrices, 3 cross 3 matrices, and we will talk about their diagonalizability. Right? Okay, so I'm just taking a 3 cross 3 matrix now, and that will be let me write a line here. This was my second remark. Okay. Let us check the diagonalizability of a square matrix of order 3. Now please get ready for long calculations, because 3 cross 3 matrix will be having 3 eigenvalues, and you will be finding 3 eigenvectors corresponding to them, and that will be taking too much time, right? Okay, so I'm taking the first question. Question number 1. This is my new question. Question number 1 for a 3 cross 3 matrix, right? If the matrix is given, this is 3 cross 3 matrix 4 6 6 1 3 2 minus 1 minus 4 minus 3. This is the matrix here. Right? First part asks that is A diagonalizable? This is the question. You have to answer it in yes or no. Second part, if A is diagonalizable, then find P is a modal matrix, a non-singular matrix. Know that it should be non-singular and it will be non-singular, of course, such that P inverse AP is diagonal matrix. And generally, matrix word is script diagonal. That's it. P inverse AP is diagonal. That's it. We don't write matrix every time. Now comes the solution, and please, those who are lacking patience, please pay attention, because patience is very important in these questions, because you have to wait for a long to achieve the matrix P. But of course, since we are having only 4 minutes, so this question will be completed in the next session, right? But of course, I will try to prove the first part as soon as possible, right? So I will write this characteristic equation of matrix A, and that is this beautiful formula: determinant of A minus lambda I equal to 0. But please pay attention. If you write determinant of A minus lambda I, then of course minus lambda will be here everywhere in the diagonal, and then you have to find the determinant, and that is not an easy task. Please pay attention. Blindly relying on this theoretical formula can be dangerous for you students, because you need you don't have too much time to calculate things, right? You have to complete this question in 10 minutes or 15 minutes, and if you spend your time in finding the determinant of this thing, of course you will be lagging behind, right? But for me, anyone who is interested can find the determinant of this matrix. Please do it in a rough copy to help me, right? Because find the determinant of this matrix, just find the determinant, nothing else, right? And जब तक आप determinant find करते हैं तब तक मैं इसकी characteristic लिख देता हूँ. इसके लिए भी shortcut version होता है. Please pay attention. I'm writing this in highlighted color. This is a shortcut equation. Lambda cube characteristic equation is this one: lambda cube minus trace of A into lambda square plus A11 plus A22 plus A33 and lambda minus determinant of A equal to 0. जब तक मैं इसको पूरा करूं तब तक प्लीज आप मेरे लिए फाइंड कर लें determinant of A. And ये फॉर्मूला होता है, दिस इज अ सीक्रेट फॉर्मूला. ओके, थैंक यू Sonu Singh, thank you, Manuel. Please others also please confirm it. Manuel, okay, now 2 people are getting same answer. I think it is correct. Lambda cube, now this is very easy now, because using shortcut tricks is very helpful for you, right? That will give you, please pay attention, lambda cube, what will be the trace of this matrix? Trace of this matrix, 4 minus 3 plus 3, that will be 4 plus minus 3. This is the trace of this matrix, right? And these are nothing but the cofactors. Please pay attention, everybody. This is the cofactor of this element. If you take this scale and if you find the cofactor of this element, like you hide this like this and this, right? You will be able to see this cofactor, right? So this is what we call cofactor of A11. Okay. So you will be having minus 9 plus 8, and that will be minus 9 plus 8, that will be minus 1. I hope you got this. What is A22? A22 is a cofactor of this element, and to find the cofactor of this element you have to hide this element like this and like this, right? Now can you see the cofactor? The cofactor of this element will be minus 12 and plus 6, that will be minus 6. I hope you know how to find the cofactors, plus minus 6. Cofactor of A33, third, this is third, A33, the diagonal third element of diagonal. This is the A33. Find the cofactor of this element, this one, this element. Find the cofactor of this element. that will be 12 minus 6, right? So that will be 6 lambda. And as the students already find the determinant of this matrix, that was minus 12, and that gives me lambda cube minus 4 lambda square and minus lambda plus 12 equal to 0. This is my characteristic equation, and the shortcut I use is this formula. This is a shortcut for this formula. This is a tip for you all. Tip is that for matrix A, which is of order 3 cross 3, the characteristic equation is given by a shortcut formula, and that shortcut formula is this one: lambda cube minus trace of A into lambda square plus sum of cofactors of diagonal elements multiplied with lambda minus determinant of A equal to 0. So this is a characteristic equation of a 3 cross 3 matrix, right? This is the formula I used here, this formula, shortcut formula, right? And now the rest of the part will be done in the next lecture at 12, right? Thank you all.